All right, in this example, a man starts 50 miles south of his home and takes a trip in his car. He travels on a long, straight north-south road, and his home lies on this road. His velocity is given in the graph, where positive velocity is northward. All right, so if the velocity is positive, then he's traveling in the northward direction. So the first question is just asking, when is the man closest to his home, and approximately how far away is he then? Okay, when is he closest to his home? Well, let's look at this graph. We have some. We're given the graph of velocity versus time, and we're told that positive velocity means he's driving north. He's driving north when the velocity is positive. Okay, which means this is where he's driving south. Driving south, right? When his velocity is negative. So if he's starting 50 miles south of his home, then you know, and then he drives north. Like he's getting closer. He's getting closer to his home, right? He's getting closer to his home until he stops driving north and he starts driving south again. Now he didn't get all the way to his phone. Let's look at how far he traveled. How far did he travel north? Now I guess I don't have to divide that into two parts because it's a triangle, right? The base is 2 and the height is 30. So this represents 30 miles north, right? So he drove 30 miles north, but he started 50 miles from his house. So his initial, here, let me write this down. Initial displacement is a negative 50 miles from his home, right? So the net change in his displacement is 30 miles toward the north. And so we can find, so we can take the negative 50 and add 30, right? So that tells us that he was within 20 miles of his home before he started traveling south again. Okay, so so we can say that after 2 hours, he is 20 miles south of his home. 20 miles south of his home. Okay, so for the first 2 hours, he's always driving north, right? He's speeding up, right? His velocity is increasing for the first hour, and then his velocity is decreasing for the second hour, but he's still going north. Okay, so he's still going north until you get to 2 hours, right? Then he's basically he slows down, and then he's driving south. Okay. All right, so when is the man farthest from his home? All right, so well, let's look at this negative area down here because this is all southward motion, right? And so I can find the area of this triangle, right? This is just a big old triangle with a base of 3, and the height is 60. So 1/2 base times height, it looks like that's going to be a total of negative 90 miles. Okay, so he drove 30 miles north, and then he drove 90 miles south. Okay, so where is he at? Where is he at? Because when he's the farthest from his home. Well, he's farthest from his home when he's driven south 90 miles. So we're gonna say after 5 hours, right? How far is he from his home? He is what? So he drove he drove 30 miles north and then 90 miles south. So he drove a net distance of 60 miles south, but he started 50 miles south of his home. So we're going to have negative 50 minus 60, right? Because that's the 30 minus 90. And so he is negative 110 miles south of his home. Let's write it down here. South of his home. Okay. So he's 110 miles south of his home. Now, another question I could have asked is how far did he drive? Well, how far did he drove 30 miles north and then 90 miles south. So he's driven a total of 120. I could even make a note of that. He drove, all right, if you looked at this odometer on his car to see how far he drove, during that time period, he actually drove 120 miles, right? This is his total, the total distance that he drove. But his position now is at the end of this 5 hours is he's 110 miles south of his home. All right, that's all I've got for you for this section. I'll see you in class.